Hello, everyone. Um, I really hope everyone is actually enjoying attending HolyJS online. I really wished, all of this pandemic wasn't there, and we were actually in sitting in the same room and talking to each other. But nevertheless, let's make use of what we have. So, welcome to my talk, Conditional Modules and Dynamic Bundling, a Netflix original. Okay, so Netflix. I hope everyone here has heard about Netflix. So Netflix is actually an online video streaming service, and we have a wide variety of content available on our website, on our mobile app, on our TV apps. So we have shows, we have movies, we have documentaries, and Netflix is also into the business of producing these movies and the variety of different video content. What is pretty amazing about Netflix is we are available in over 190 countries, and we have close to 170 million paid subscribers worldwide. So, hashtag Netflix everywhere. So, let me start by introducing myself here. So, I am Rajat. I am part of the Netflix's TV UI Foundation team. And what my team does is they provide the building blocks for our engineers to write and run JavaScript and React on TV-like devices. When I say TV-like devices, I mean something like your Samsung TV, your LG TV. It also includes PlayStation. It also includes Xbox, Fire Stick, Roku, and all the streaming devices that are available in the market. So, having said that, the TVUI Foundation team is also responsible for making sure all of these JavaScript files that engineers build can be delivered to these devices. And not just to these devices, also on our Netflix.com website. So today I'm going to talk about how we bundle JavaScript at Netflix. So this talk is primarily about how we challenged some of the common conventions and how we actually ended up solving for our own problem. And every tech company has their own different set of challenges. At Netflix we have our own challenges. So some of the concepts that I discussed in this talk might be relevant to you, and some of them might not be. But at the end, all I want is all the engineers to understand that JavaScript ecosystem in itself is really flexible, and feel free to bend the rules, feel free to challenge the conventions and solve your problems. Okay. All right. So this talk is split into four parts. So I will start by talking about the problem. What exactly was the problem that we faced and how we planned to solve the problem. And then I will go into all the different types of options that we chose, why we chose those options. I will talk about some of the concepts that we built for our own self, for our own understanding. And then at the end of it, I will end the session with, with the fact that, okay, what is coming in the near future for our team. So a little bit of background about how engineering is at Netflix. So Netflix is a data-driven product development company. So that means at Netflix, we do a lot of A/B tests. When I say a lot of A/B tests, I really mean a lot of A/B tests. So, what we try to do with these A/B tests is we try to gather information and the data and try to get a sense of what's working in the product and what's not working in the product. Like what is it that people can easily interact with, and it's pretty frictionless versus what becomes a lot more friction, right? So now, given the fact that Netflix, the engineering culture is so much data driven, what happens is all the engineers always keep A/B tests in mind whenever they are building any new feature. So here you can see, a Netflix.com website. So when you log into Netflix.com, you are greeted by a UI which is something very similar. And all the UI engineers out there can very easily identify that, okay, this page itself consists of, so many different types of components in them. right? So I have marked a few components, and then, now this is much more easier to understand, that you have a component where we show those images of, the box art of the video. Then we show the title, we have those buttons. But what happens is all the things that I've highlighted here actually have been A/B tested, not just once, but maybe several times. Like, we test out every little detail on the UI, like where should be the Netflix logo on the images, like what should be the margins or the gaps between those images, how big should be these images. So all of these things are being A/B tested. What this also means is when we run these A/B tests, uh, you might be subscribed to an A/B test while one of your friends might not be. So that means there is a unique experience that every subscriber ends up seeing, right? Sometimes these differences are so subtle that people don't even notice. And it's not just A/B test that changes your experience. Your experience also varies based on which browser you are on, or are you accessing it from a TV device, right? So now let's talk about what are the challenges that come up when you are trying to A/B test a UI. So on the screen, you can see that I've highlighted the search box. And let's assume, we are A/B testing two versions of the same search component. So essentially, uh, I'm really bad with naming. So let's just call these two experiences as the current search experience and the new search experience, and assume that our engineers have already built it. So what is the first thing, or what is the most important thing that we have to do to make sure that somebody can run these two variations? Well, the most basic thing is to ensure that all the JavaScript code needed to run these two experiences, the new search experience and the current search experience, is actually delivered as part of the bundle to the devices, to the browsers, right? And that is where our team comes in. So we are responsible for bundling together all the JavaScript and pushing it to our clients. So you can imagine that the JavaScript code would look something like this. So you have an entry point, app.js, and then you have these two search components, the new search component and the current search component. And these components actually have their dependencies and sub-dependencies for it to execute. And so what happens is if a subscriber gets the current search experience, that means we have to ensure that app.js, the current search component, and its dependencies are actually available in the bundle. And likewise, if the user gets the new search experience, right, then we need to ensure that the dependencies and the sub-dependencies for the new search experience actually exist in the bundle, right? So you can imagine how people write code for this. So most developers, what they will do is they will import the current search component and they will import the new search component. Pretty standard. And then somewhere in the render function, uh, based on a Boolean flag, you just display one of the search components, right? This is a pretty standard way of writing React code. But do you notice something? That even though we want to render just one component, right, we are including all these files in our bundle. And that's because we just said import current search and import new search. I hope at this point you would be seeing the problem. Like, what's the problem now, right? So we are importing two components and knowing the fact that only one of the components are ever going to be displayed on the UI. So several of these files might not even execute on the client side, right? So that was the initial problem that we saw, that we were still packaging two mutually exclusive code execution paths together. The fact is, Netflix apps are already pretty huge. And when we put together all these multiple experiences in one single bundle, these apps become even bigger. So after all the optimizations and minifications, we saw that our website was like 10 megabytes of JavaScript. our television app was almost 30 megabytes of JavaScript. Do you think our users will ever appreciate downloading like 10 megabytes of JavaScript on their browser? I mean, I as a subscriber would just hate it. So what happens with these huge apps is that first and foremost, we see really slower performing apps. These apps are really slow to start. It takes so much painfully longer time to load and for our users to even start interacting with them. So the end result here is that it's actually a poor user experience. So the challenge in front of us at this point was, can we really do something to improve the user experience? Logically speaking, maybe we can build smaller packages, and these packages could be like very specific to a user's A/B test. Sounds logical, but can we really do that? Like, is it really possible to build smaller packages that are like tailored specific to a user's A/B test allocation, or tailored to the fact that which device they are accessing it from or which region they are accessing it from, right? Turns out for Netflix, the answer was no. Uh, we run hundreds of A/B tests. And when we run hundreds of A/B tests, it actually has some side effects. So in the next couple of slides, I'm just going to dig into, what exactly are the side effects of running so many A/B tests. So when people think about A/B tests, they typically think of two variations, like variation A and variation B. Uh, Pretty standard. That's why they are called A/B tests. But at Netflix, we do multivariate A/B tests. What that means is it's not just two variations. We might have more than two variations. Uh, in most of the cases, it's at least four variations. Okay. And each of these variations means the UI appears slightly different. So for our subscribers, it's a slightly different experience. And additionally, it's not just one single multivariate test. We actually run multiple multivariate tests, right? So we have hundreds of A/B tests, and all these tests have different variations in them, different test cells in them. And we have so many tests trying to gather information about what is a user's preference at the end of the day. So the way a subscriber gets allocated into these A/B tests is pretty random. Okay, so as long as a subscriber meets a criteria, they can be allocated into one of the test cells. That means, for example, if you are still running PlayStation 3 or Netflix app on PlayStation 3, and there is an A/B test for PlayStation 3, you might get allocated into one of the test cells. And as soon as you are allocated into one of those test cells, your UI experience might be slightly different. Okay, so at this point, we run hundreds of A/B tests. So the question comes back to say that how many packages do we need to build and serve? So we talked about building smaller packages, but how many packages do we need to build and serve? If you take any guesses in your mind, please do let me know in the chat afterwards, like what is your initial hunch? Uh, so I'll go forward, and the math here is pretty simple. Uh, it's basically the Cartesian product of number of test variants in each test. So for example, if I have four variations in each test, so it's just going to be 4 into 4 into 4 into 4, so just the Cartesian product. Now to actually understand, how difficult it is, let's simplify this a little bit, okay? Let's say instead of running hundreds of A/B tests, we just run 15. And for these 15 A/B tests, we have four variations. So that means how many bundles do we need to produce? We have to produce like 4 into 4 into 4, 15 times. That's 4 to the power 15. And this number itself is pretty mind-boggling. That's over a billion. Yes. So think about it. Just with 15 A/B tests having four variations, we are already talking about a billion packages, a billion smaller bundles, right? But the fact is, it's not 15. We are actually running hundreds and hundreds of A/B tests, right? And if assume we have hundreds of A/B tests with 4 variations each. We are looking at a pretty huge number. And this number is actually so huge that I cannot even put them on these slides. So at this point, I hope people are clear that, mathematically we have calculated that we probably need to serve billions of, smaller packages. Now comes the second part, which is, if we need to really build these billions of packages and time taken for like one build is like 2 minutes, how much time do you think, it takes for a billion builds? And not just that, we have two different apps using the same mechanism. So we have our television apps and we have our website. So that means we are actually building and deploying for both the web and the TV. So now think about the time taken for the builds. And that's not it. We have more. We actually deploy at least 3 times a week into production. Now imagine the time taken to do all of this work for billions of packages. So at this point, when you go through these numbers, it is pretty unreasonable to say that we can actually build billions of packages. So the actual problem in front of us was we still need to serve billions of smaller packages that are very specific to users' A/B tests. And at Netflix's scale, it is like really next to impossible to do that. So what we did was, we dressed up like defenders and we said, we have to solve this. I mean, it's an interesting problem. We have to solve this. So we were as serious as Luke Cage and Jessica Jones on the screen. I always think that I was the guy dressed in the suit, the daredevil. And we actually thought pretty hard about solving this problem. And we said, we do have a server. And what if we can actually build a service that could package these files quickly, like at the request time? We package the files and those packages are like really small. If we are able to do it effectively, then maybe we are solving our problem. So what we were talking about was actually generating JavaScript bundles on demand at request time, right? But building a dynamic bundling service or building these JavaScript files at the runtime isn't easy. But we were at it. We decided to solve it. So we started breaking down our problem and we started thinking more about it. So at a very high level, a generic build process should look something like this. So you have our, we have our TypeScript files, we have JavaScript files in our Git repo, and we needed some mechanism to transpile them and optimize them, but also keep track of the fact that, okay, these are the points where you can determine that these files need to be in package A, but need not be applicable to package B. And these are the files that needs to be in package C and also in package B. So there are complexities involved, but the essence was we needed a build step which could actually give us this information and produce and probably even produce the packages. So we started solving for this and we thought maybe we could just do a static analysis of the code. And turns out when we looked back at the code, we saw that it was possible. So what we saw was in our code base, most of the times, whenever there are UI features or UI experiences, they were always gated or blocked by a Boolean flag, right? Which was pretty straightforward. Like if the new search exp variable is true, that's when you show your new search experience, right? And this is a pretty common practice. And we went back into the source code and we saw this pattern all across. And that is when we thought that, yes, maybe if we do some static analysis, it is possible to figure out the set of files that need to be included or excluded based on a Boolean value. So going with that information, we said, yes, probably we can do something around static analysis. The next problem that we ran into was if we are building these billion packages, how do you version those billion packages? So we came up with an idea of saying, what if we don't build the packages? Instead, we just store the metadata somewhere. And when we store this metadata, can we categorize the metadata into logical groups? And this grouping was what we were calling artifact. So all capturing all the metadata from our Git repo and putting them all together in a logical group was something that all of us agreed on. It made more sense to us. So in reality, what we wanted to see was with every build, we have this bunch of artifacts that get generated, and that only primarily contains the metadata of your source information. So this is something that we imagined we can solve on the build side. But on the server side, we needed the same artifacts to be available. Plus, we also figured that our server could actually bundle these files only if our clients give us all the relevant information. So we expected our clients to provide us with the fact that, okay, which version of the artifact do you intend to use, or which file do you intend to bundle? And also, of course, give us the user info so that we can figure out what are the A/B tests applicable for this subscriber. And then we could just bundle all the JavaScript assets and send it over to the client. But having said that, there was still a problem, a minor problem, which is around CDN. So Netflix, we want our assets to be really, really, we want to deliver our assets really, really fast. So, and we leverage CDNs a lot. So whatever be the solution, we wanted to make sure that our solution works with the CDN as well. So that means, if a request comes for a file, maybe the first time the server is able to serve it, but the subsequent requests should always be served from the CDN. So after actually laying out all our requirements in one place and trying to strawman the solution, we were very clear about one thing, that we needed to solve this in two parts. The first was the build part, and the second was on the request part, right? So on the build side, what we want to do is we wanted to do some static analysis, figure out all the Boolean flags that our engineers are using, right? And create some sort of a metadata around it. And on the second, on the request side, what we wanted to do was, whenever a device asks for a JavaScript package, we would apply some smart resolution logic, figure out the list of files, and then cobble them up together and send it back to the device, to the browser, or to our TV UI. So now we started implementing this. And for the request side, we decided to use Node.js. The reason why we stuck with Node.js was, first of all, we found it really powerful, even within our Netflix ecosystem. And second, we already have a lot of super JavaScript engineers who were like really, really comfortable building, distributed systems with Node.js. So that worked on our favor. And then for the build side, we said, we could just use Webpack. And there were a couple of things that actually worked in the favor of Webpack. The first and foremost was Webpack is really, really customizable. It has all the set of right hooks, and it can be really customized to the way you want it to. So that was the biggest compelling factor for us. The second thing about Webpack is the great ecosystem of plugins. So I don't have to write another plugin to parse my TypeScript files. I don't need to write, different configurations to optimize the bundle. I mean, there are so many known stuff around Webpack, and that was amazing. And the third thing that we liked about Webpack was the fact that most engineers at Netflix were very comfortable working with it. So they could just fine tune their build process the way they want. So without us interfering, they could optimize their bundles the way they want to. The delivery would still be with us, but how small or how big or what kind of transforms that they want on their source can always be handed off to the individual teams. right? So we started building more on this idea. And what we figured was from our source code, we want a build process using Webpack that actually outputs something called an artifact. Okay. And you can think of this artifact as the critical key in all the process, in all the processing. And it was very important for us to start defining what this artifact should be. And we narrowed down on three primary things that this artifact should have. So first and foremost, this artifact should know the dependency graph. So when I say dependency graph, all I mean to say is the relationship between the different files in your source code. So that's your dependency graph. So in our case, app.js depends on the new search component or the current search component based on which path do we take. So that's the dependency graph. The second thing we needed to know was the metadata on resolving the files. So for example, if certain condition is true, should I include the file or should I exclude the file? So that sort of metadata around resolving these files needed to be there. And third, and the most important, was the transpiled and the optimized source code of all the files. So now you can imagine that this artifact is like a snapshot of your source code when it was built, because it already contains all your source code with all the dependency graph information and all the metadata on top, right? So artifact sort of becomes the bridge between the build time and the request time. So on the request time, what we wanted to do was, okay, request comes into the system and we just look at the artifact and then we do the magic of bundling the files and send it back to the user, right? So at the end of the day, we decided, okay, this seems reasonable. And now let's start building on top of this. So when we started building, uh, we explored how to solve this problem. And we wanted to keep the solution in a very clean fashion, something that everybody can understand. Not just us, even like a regular engineer who's working on the UI should not feel, scared of understanding these things. So we introduced the concept of conditional modules. Now let's explore what this actually means. So, as I said earlier, our build process is pretty simple. The build involves Webpack, reads our Git repo, generates this artifact, right? Um, and what happens during the build process is it looks for these Boolean flags. So as I explained this earlier, that if new search experience is true, you want the new search component to be included, followed by all its dependencies and sub-dependencies. So how we define a conditional module in this particular case is that the flag new search experience, right, that becomes your condition. So this Boolean value is the condition, and the incoming, or let's say the primary file involved, which is the new search file, that along with all its dependencies and sub-dependencies becomes one single module. So once you start imagining your source code in this fashion, you can very clearly identify, okay, that these are the files that are like regular modules. They are not blocked by any Boolean value, versus there are some modules that are actually blocked by a Boolean flag, and they are my conditional modules, right? So in this particular case, what we are saying is all the files needed by the new search component to work properly, right? That forms the module. And this module is actually controlled by our Boolean flag called new search experience. Cool. Now, like every engineer, we dig in and we said, okay, conceptually, conditional modules make sense, but how do we mark a module as conditional? Like, there is no concept of conditional modules in JavaScript. There is no concept, these concepts are pretty new. Webpack doesn't understand all of this, right? So we took a pretty new approach to it. We said, okay, how about we introduce new syntax in the code? How about we make it really explicit in the code that this module becomes conditional. So the first syntax that we introduced was a code comment on the top of the file, which is @ condition followed by a Boolean flag. So this was the first syntax. And what this means is that the new search file itself is saying, hey, I should be included into the bundle if and only if new search experience Boolean value is true, right? So this was self-explanatory, but it's still a code comment. So that was the first syntax that we gave to our engineers. The second option that we gave to our engineers was using a $conditions keyword. So, and this allowed our engineers to actually write if and else statement. So what we are trying to say here is that, okay, in this particular case, the parent file says, should I include new search or should I include current search? So in the syntax, the first syntax that I showed you, in that the file itself is saying the reason when it should be included, versus this second option where the parent file is trying to figure out which file should I be importing. And I know this $conditions keyword sounds really funny, but this actually makes our engineers' eye pop out when they look at the code, and it actually makes it very clear saying, okay, hang on, this is something different. Oh, this is a conditional module, right? And what we wanted to do was we wanted Webpack to understand these two syntaxes. So essentially, with the @condition comment and $conditions keyword, we were actually able to mark these modules as conditional. So what happens with this is this helped us resolve the metadata to figure out, what are the different conditions and what are the different conditional modules. So now we have that part of it, but we still have a lot more to do. So in our artifact, we said we need a dependency graph, right? And what we also want is, it's not just a dependency graph, we needed a conditional dependency graph. So at this point, you might be like, what exactly is a conditional dependency graph? Well, it's pretty straightforward. It's a regular dependency graph, and just apply all the metadata that we collected on top of it. So essentially, all the edges uh, can be conditional or non-conditional. And the walking, if you walk this particular graph, you can only walk if the edge is non-conditional, or if the condition is true, that's the point you can walk the graph. So conceptually, we just take the dependency graph, apply the metadata, and we get the conditional dependency graph. And what did we want to do? We wanted our Webpack to give us this conditional dependency graph as its output. So now the next obvious question is, how exactly do we build this conditional dependency graph, especially with Webpack? Well, for us, the solution was pretty straightforward again. What we did was we built a Webpack plugin. And what this Webpack plugin could do was actually read the AST, or the abstract syntax tree of the file that is being parsed. So for this, we relied on the program, on the parser's program hook. And what this hook does is, any file, any JavaScript file that it's reading, it gives you back the AST. And then what we did was, in that particular syntax tree, we would just look for our special conditions. So the two conditions, the @condition comment and the $condition syntax. And as soon as we would find this, we just stored this information in the cache, in the Webpack cache itself. So this way, as the build is progressing, we are collecting all the information about conditional modules in our source code. The beauty of Webpack was it actually has the full dependency graph already. So when it parses and looks at all those files, it's already building a full dependency graph of the code. Plus, with all the loaders and stuff, it was actually able to transpile and optimize our code already. So Webpack actually gave us all these things out of the box. And then the final thing that we had to do was tap into compiler's emit hook, extract all this information from Webpack, and just serialize it into a JSON file. And what we got at the end was we have a build process using Webpack, using our plugin. We generate this conditional dependency graph information, and we just serialize it into a file, which we are calling as our artifact, right? So we have managed to actually get the dependency graph, the metadata, and the transpiled source code. So at this point, we have our final artifact that we need, but this is just the first half of it. This is just the build. So now let's talk about how we are bundling all of this together on our servers on the request time. Okay. So if you recall, what we wanted to do was client makes a request, the server then looks into the artifact, bundles all the JavaScript file together and sends it back, right? So that was the contract. And the other thing we wanted to make sure was all the responses from the server actually can be cached on our CDN. So we started writing this service out, and we named our bundling service as Codex. And the whole idea was Codex, you can upload the artifact files to the Codex, and then Codex should be able to, start resolving the files. So the next question for us was, okay, I understand the concept. I have a server, I have the artifact. How do we actually resolve conditional dependencies at runtime? Right? That's the big question. So to resolve any conditional dependency, what we figured was we needed two pieces of information. So one was the actual artifact, which is already available on the server. That's what we started with. The second was the server needs to know, who's the user, what are the different A/B test allocations that are applicable, which device is it, and of course the fact that which region they are from, right? All this, the user related information was something that we needed to resolve conditions. And all this information can be easily sent from the client, can be easily sent from the browser. So that's how we started to work on the resolution part. And we figured that the best mechanism to gather this information was in the URL itself. So as you can see, the URL here is actually templatized. And this templatized URL gives all the information that's needed for us to start resolving the file. So it's like, it's a self-contained URL. It has all the information that we need. So for example, this URL is saying, okay, I'm looking for the web UI app and give me the version 3 of the web UI app. Start with the file app.js. So that's the entry point. And by the way, this user is allowed to see the new search experience and the smart playback experience, right? So you can see that this URL itself is like self-contained. It has everything that we need for resolution. So what happens on the server side? So our Codex gets this URL request. And what it does is, okay, it figures out this is web UI v3. And then it extracts these conditions and says, oh yeah, you are telling me that the new search experience has to be enabled and the smart playback has to be enabled. And we store it in the bag of the options. So our options actually now have these two values. And then we know the entry point as app.js, and we start traversing our conditional dependency graph from app.js. I hope this is not too much of information, but yeah, let's go into how the graph traversal actually happens. So we start with app.js, right? And the traversal algorithm is pretty straightforward. You can traverse the graph only if the edge is either non-conditional, or if it has a condition, then that condition has to be true. And you can keep on traveling until you actually hit a conditional edge. Okay. So in this particular traversal, if you see, app.js is already met with two dead ends. So two edges that are marked as condition. So at this point, the algorithm just looks into the bag of options and it sees that the new search experience is true. So that means it can actually go down that path, and it can go down that path until it's actually hit by a new set of edges that are conditional, or there are like leaf nodes. So in this particular case, again, this example, we see that it goes and it's now stopped at the smart playback edge and the smart session edge. So again, we look back at the bag of options and we see that, okay, smart playback is true. So we pick that side of the graph while we ignore the smart session. So at the end, what happens is with these two options enabled, this is the list of files that we get from our conditional dependency graph that needs to be included in the bundle. So as you can see, my original conditional dependency graph was much bigger, but now with that new traversal algorithm, we just got a very tiny piece of it. And that's the smaller package that we want to build and serve. And that is exactly what Codex does. So what Codex does is it gets requests from both TV apps, from the website, and the URLs itself tell us like, okay, look for so-and-so version, look for this entry point, and bundle them together and give us back, right? So this is how Codex actually behaves. So at this point, I mean, a lot of you must be wondering, like, isn't this graph traversal really, really slow? I mean, if we have like 2000 files, which is actually the case, isn't the whole traversal really slow? Well, turns out it was slow initially, but then we actually worked on a lot of optimizations. We used memoization. We used multi-level caching for storing all the information in the artifact. We also tried and improved the way we store information within the artifact. And on top of that, all this information is actually in memory. So there is no database request, there's no file reading that happens on the server side. And we were able to bring down our response times to be less than 70 milliseconds. So the 70 milliseconds number is for our website. For our television app, which is like a much bigger app, this timing was around 250 to 300 milliseconds. So and these are all P95 latencies. So think about it like that's almost the maximum that we see, because most of the requests actually are handled in much lesser time, right? And we are still actually trying to optimize this even further. We want this number to go down even further. And the other thing that we always talked about was CDN, right? We don't want our Codex service to reprocess the same URL again and again. And we said, we had to use CDN. Can we use CDN? And turns out the very fact that we have the templatized URLs and the URL is self-contained. So that means as long as you give me the same URL, the output from Codex is always going to be the same. So that means that this helped us use our CDNs even more effectively, right? So this URL trick actually helped us make sure that all the JavaScript bundles that we serve are actually cached on the CDN, or rather cacheable on the CDNs, right? So that is exactly how we solved the whole problem of A/B tests leading to multiple bundles, and then how we actually changed from instead of building the bundles beforehand to dynamic bundling. So let me summarize this whole process again for you. So what happens is our UI developers clearly mark conditions in their flag. They tell us these are the conditional modules using our two syntaxes, the @ condition comment and the $conditions keyword, right? And then what happens is Webpack runs with our plugin, looks at the source code, and then it figures out all the dependency graph, all the conditions, and then it serializes all the information, including source code, into our artifact file. And these artifact files are actually versioned. So every build would actually have a different version. Then we actually give these artifact files to our Codex service. And Codex is our dynamic bundler, or at times we also call it the bundling as a service for Netflix. And our Codex, once it has the artifact available, is ready to respond back to the user request. So any request for the bundles that or the JavaScript assets that come through into the system actually comes through CDN. So that means that once Codex has generated a bundle, it can sit on the CDN for the subsequent requests. So we are not reprocessing the same request again. So that is what we actually ended up building. And building this whole system wasn't easy. I mean, we stumbled a lot. We ran into a lot of issues while we were optimizing. And as I wrap this talk here, I just wanted to talk a little bit about, what are the next few things we plan to work on. So one of the things that is pretty important for us is the developer experience, and especially with Webpack. So Webpack is a great tool uh, with the hot module replacement, with source maps availability. I think it's a pretty strong tool in the community. But unfortunately, with our system, the way we've built it, we were not able to leverage most of them. So because we are bundling so many things dynamically, it became hard for us to actually keep track of the source maps. So unfortunately, developers don't have access to source maps. Similarly, because now it's a broken process, you generate an artifact, and then artifact is used on the service to serve the final bundle. That also means that the hot module replacement option was not available for local development. So we are still working on fixing these. So as of now, we do have a minor tweak available where for your local development, you don't go through this whole process. Instead, we've actually added some smarts so that Webpack itself or the Webpack dev server itself can serve the files. So some of those problems have been eliminated, but it's not up to the mark yet. So local developer experience still is lacking. The second thing that is actually bothering us right now is the life cycle of the artifacts. So as I mentioned, we actually do 3 builds to production every week for both TV and for the website. What that means is that every week we have at least 6 new artifacts being generated in production. And maintaining all the information of these artifacts in memory becomes very expensive. So we are still figuring out how or what's the best way to manage these artifacts. The other use case that we have is that some of the older devices are actually pinned to the specific version. So for example, some of the PlayStations, PS3 specifically, are actually pinned to a specific version of the bundle. So that means that can never be moved out of the memory. They have to be there available on the Codex servers. So that means if it's not in memory, if we are trying to read that file again and again, it slows down the whole process. So these are some of the things that we are trying to solve for. So I hope this talk inspires you to ditch the conventions and start challenging the convention, challenging what's already out there. I personally feel that JavaScript ecosystem is really flexible and it allows you to build whatever you want to build. Like, use the flexibility of the ecosystem. So that's all for today. And again, I'm available on Twitter as Rajat Kumar. So feel free to reach out. Feel free to ask questions. Thank you. Have a great day and stay safe.
Yeah, seems like I'm online. So yeah, Rajat, thank you very much for your talk. And indeed, we have a few questions from chat. And yeah, let me announce some of them. So the very first one is about timing. So lead time between the idea and the implementation of this idea. So how much time it took?
So for us, it took about close to 9 months. 9 months is when we actually had the first version working on production. But yeah, and everything in production in about like a year and 2 months. So we started experimenting it with this new stuff on production in about 9 to 10 months, and then have it fully in production in about 14 or 15 months.
Yeah, thank you. And the next question is about the URL string, because as far as I know, and as far as guys from the chat know, if it's a GET request, there is a limitation on size of this request. So if there is a lot of tests applied to this request, did you face with this issue?
Yes. So in this presentation, I tried to keep it a little simple. But in actual reality, what happens is we use encoded values to figure out what are the truths or what are the conditions that needs to be enabled. So they don't really go like a full string. It's actually a binary version of the string, or let's say a stringified binary value. And we just look it up on the bits which say that these are true, and then just enable those experiences. So as a matter of fact, I would suggest if you actually go to netflix.com, you can look at the URL and you will see that it follows the similar template, but those template, the values are actually not, very human readable. They are not really English words. You will find some characters because those are all encoded values. So of course we ran into this like on the very first day.
Try emojis. Like,
that's a brilliant idea. Maybe next time.
Yeah. The next question from chat is regarding bug hunting. You already touched a bit this topic during your speech, but yet. So if someone finds a bug, how do you really understand what is the version? So how to re-implement this environment, how to reproduce it?
Okay. So what happens is, again, as I said, we run a lot of A/B tests. So it's a very, very common scenario to run into issues because of A/B tests to start with. Like, what if some of the A/B tests are not configured, or what if two tests actually conflict with each other? And the chances of actually having a bug is like really, really high. So what we have is we have something called a pseudo prod environment, which is just the replica of the same. And as soon as we hit a bug for a particular user, we know the URL. So you can always tag the same URL on this new environment and get back the same bundle, right? So that's like the most basic initial triaging. But the reality is, even before you do this, we actually collect a lot of logs as well. So you will have a lot of background information about, what the user was trying to do, or which screen did they run into, what was the actual exception. So right now we don't have the source maps. Again, nobody gives out source maps even prod, but still, even for local development, it at times becomes a little bit challenging because of that. But then so far, with the help of logging, things have been like, it's not been like a nightmare to debug, but it's a pain point at times.
Yeah, and you already answered the next question regarding if you have an environment for that. So yeah, you have. I also have a few questions prepared during your talk. So the very first one is regarding how do you think is this approach applicable for any other product except Netflix?
I'm not too sure. I would say if there is a need where you cannot determine what's the JavaScript asset that you need to serve, maybe that's the only use case where you will use something like this. So I'll give you like a small example where this was pretty useful for us. So apart from our own products, there are like few internal applications that people build and use within Netflix. And there was this typical use case where this team was like, our UI actually changes based on what the service or the server responds back with, which meant that if the server says XYZ, I'm supposed to show an XYZ app, versus if the server says ABC, I show the ABC app. So think about like two different apps completely determined from the server side. Like, okay, this is the apps the user sees. And that was a compelling use case for this team. So what they did was applied the same Codex servers. So they built both the apps, and based on and now what happens is like the server itself is saying, hey, use so and so app, and by the way, this is the URL script that the browser should just load. And they were actually able to mitigate or solve this problem just with the help of Codex. So no external code required. All they had to do was build those different varieties of apps, and the server would just say, or just add the right script tag in the HTML, and it would just pull in the right application. So I mean, within Netflix, we've seen the use cases, but I would imagine any company that has a lot of A/B tests can definitely use the system. But yeah, I mean, honestly speaking, this is a Netflix specific problem. I haven't heard of anybody else see this problem.
But yet, here comes my next question. If you have any plans of like making Codex public or even open source?
Mm-hmm. We've been talking about it. I don't think a final call has been made. And the primary reason for not open sourcing this has been because our services are like really tightly bound to Netflix's infrastructure. So the way Codex service has been written, it's a little difficult to like just deploy it anywhere. But what can be easily open sourced is our Webpack plugin, because that is completely dependent on how Webpack works. So right now, our plugin works with only 4.x, not the newer 5.x. So again, those are some of the things that we have to handle. But yeah, I think over time, once we figure out what's the value that this actually has, even for the open source community, I think we will try and open source it out.
Well, we've got. Thank you for your answers. We've got another one question from chat. So it sounds like, why don't you use many chunks? So you can just load them on demand from your browser if it needed.
I was hoping that somebody would ask this question, and I deliberately did not add this point on my slides. And the primary reason why we don't do chunks, or let's call it asynchronous loading of the bundles, is even those individual bundles that we have are like so many of them. So during your interaction with the app, if I were to load 5 bundles after every different interaction based on the A/B test, the overall experience again becomes really, really slow. We've seen that on browser. And then for the television apps, there is even more limitations for us. So there are some devices that are really low on memory. And what happens is, as soon as we try to asynchronously load new bundles, the apps would just crash. And we've seen that issue in the field. So our original idea was to start using asynchronous bundles. And then we realized that, not all problems can be solved with asynchronous bundling. So we decided to say, okay, just take this one whole bundle and just run your app on this. To add to it, very recently, we actually started doing asynchronous bundling using the Codex itself, using the same concepts of conditional bundling. And what that means is you can now asynchronously request for new set of JavaScript files, and that will also start resolving based on your A/B test and give you back one single bundle. So instead of like now taking asking for 5 different bundles based on your allocation or A/B test allocation, you still make just one request. We give you back that set of files, and you can load them asynchronously. So we do have that prototype working. It's not in production yet, but hopefully we'll be doing it like in a couple of months.
Yeah, well, thank you. Thank you for a great and pretty big and extended answer. The next main question is regarding this versioning of components, right? You've said that it could be like in average 4 version for a component, right?
Yep.
But
So
yeah,
mhm.
the question is, do you have a component that is the most tested, and what is like the maximum amount of tests applied to one component? Kind of record.
I don't remember, or I'm not really aware of it. But something that has been tested really, really, really frequently has been the rows of movies that you see, especially the first row, uh, because it's the first row, and product managers just love it. They want to make sure the best of the best kind of gets highlighted there, and they experiment a lot with it. So I know that section of the UI gets a lot of A/B tests, a lot of variations, and changes like really, really frequently. Some of the changes are just visual. Some of the changes are like the back-end algorithm of like how the ranking of the videos shown should be. Some of them have been like completely, way outside of what Netflix generally does. So it's been fun watching these A/B tests roll out. But yeah, I think I would say the first row that you see on the UI, that's like the most A/B tested.
Yeah, well, it makes sense. And the next my question regarding versioning and components, do you store these components somewhere? So do you use kind of design system for that, like Storybook, I don't know, just to keep it
Um,
tracked?
so Netflix actually has, so product managers and the designers work really closely, and we do have like a basic set of design system available. But then, I mean, it's there. I haven't personally ever had to use it or interact with the UI engineers who actually do all the designing for us. So I know that there exists this design system, but I haven't really used it.
Yeah,
Yeah, there's a
well,
whole team that does it.
yeah, so let's move closer to your like area. So there's two kind of professions. The very first one is front end engineer, right? And the second one
Mm-hmm.
is development operations, so called DevOps. Yeah. And what do you think about creating a new one called like front ops or front end ops or something like that?
That is pretty interesting. Um, so one of the things that I like about Netflix is you operate what you build. So what that means is if you build a service, you are the one who's also operating it. If you build a fancy UI, you are the one who's also operating it, all managing all the tests alongside it. So for us, it's always like a holistic responsibility. So you are not just a person who's doing the search experience. If you're doing the search experience, that means you also need to understand what is the data, where is the data coming from. You are working really closely with the backend engineers as well. So you technically operate what you build. If there is a bug, you take the ownership and you go and solve it. So for us, I mean, at Netflix, we don't really have a DevOps sort of team because the engineers themselves are like highly integrated and working together to, be that DevOps as well. So I would say that we are already front ops in some form.
Okay, we've got another one question in chat.
Mhm.
Do you use some special database to store artifacts?
Well, for us, it's not a database. Actually, I will take it back. So the actual artifacts are still stored in S3. So when the build happens, the build process actually stores all these huge files in S3. And the versioning information is actually just stored in DynamoDB. And when Codex servers come up, there is an initial pipeline. What it does is it extracts all the artifacts from S3 into an EBS volume and then attaches that volume onto the server. So essentially that means is when Codex server comes up, it already has all the artifacts on its hard disk, and all it needs to do now is parse the files for one, like just once, and keep everything in memory. So yes, the artifacts are in S3. The versioning information saying this artifact is version v3 for TVUI, this exists in DynamoDB. And what we do is when those artifacts are pulled in, that's also the time when we take that snapshot from DynamoDB and store that information and maintain the maps.
Yeah, well, just to make it clear, when you say S3, you mean Amazon Web Services S3 bucket,
yeah.
right? Yeah,
Yes,
and DynamoDB. Yes. Yeah, okay. And I have also one more question. You have shown some code in your talk on your slides, React code, I mean, and you've said that there are some conditional modules, and to define the condition by itself, you use a comment in the very beginning of the file, and inside this comment, you write the name of the condition.
Yes.
And my engineering mind told me that, well, it's kind of hard code. So what happens if you need to change this item? So what do you do? Is just Command F and replace, or what?
So think about it like this. Generally, this particular comment goes on just one file. Mostly, it will happen only in one file because whatever is your entry file that governs the whole feature is the file where you will have this flag. Because as soon as this flag becomes false, all its dependent files will be ignored by the build. Like they all become one single conditional module. So generally, we haven't seen cases where somebody has to go and repeatedly change those values. But again, having said that, because it's a code comment and it's a string that people are looking for, that's a problem. So that's why we actually have the other way of defining conditions as well, the second syntax of using if-else statements. So we have like two variations of it. So when you put it in the code comment itself, that's like when the file is saying, hey, you can only include me if this is true. And now the file, or let's say the whole conditional module, is saying that you can only include me if this is true. But in case of the if-else syntax that I showed, it's like the parent file is governing, should I include this child or not? Should I consider this child as like whole conditional module or not? So there's a subtle difference, but it is pretty strong. Like one example I'll give you is on the website, we said we were trying to compare between two different animation libraries. So how do you compare between those two animation libraries? We said just add an entry file for both those libraries and give them two different truth values. And that was it. So from a require perspective, we're just saying require library, and the build itself is able to identify based on what the truth condition value is to say that, oh, because Lottie is true, let me just go include Lottie library. Because something else is true, let me just go and include the other one. So it's got its own powers in some sort, but yes, both the syntaxes have been useful so far.
Well, okay, thank you. I have another one question. You've said that the lead time from like the idea till production was kind of 9 till 14 months, right?
Yeah.
Something like that. But what was the size of the team?
We were 4 people, and later we increased to like 6, and now we are back to 4.
Okay, I see. And probably the last question for this session would be regarding your favorite Netflix original show you recommend to take a look.
My favorite is actually Stranger Things. I enjoy the show so much that it makes me feel like I'm a kid again. So Stranger Things is my favorite, and I would highly recommend people watching it.
When the season number 4 will be released, tell us please, because I'm waiting. Yeah, I'm just joking. I know about
I'm pretty sure it's gonna be released soon.
Yeah, good news. So we have 5, 4, 3 seconds. Thank you very much for your time, for the talk. It was great.
Hi.
Thank you so much.
Thanks for the talk. It was amazing. I'm also waiting for the fourth season. And I'd like to remind you that everyone are welcome to join a conversation in Zoom where you may ask questions to Rajat about the talk. Please find the link below the video. Bye, guys. Thank you very much.
Thank you.
Thank you.
See ya.